Okay, second part is about department employee. We have already studied. So here, department employee, we talked about three relationship: employment one-to-many relationship, management one-to-one relationship, recursive supervised relationship. And for each relationship, we talked about foreign key and the primary key. One-to-many relationship, employment. Here, department name matched with department name. And the one-to-one relationship, department employee number. So this is manager number matched with employee's employee number. The most tricky part is recursive relationship. So employee as worker's boss number is matched with boss's employee number. So let's review one more time with some similar practice examples. The first one is find the names of Sophie's boss. So the answer is Alice. So let's look at the data first. So here in the employee table, we are looking Sophie. So employee first name Sophie here. So when you read this data Sophie, we are looking at this employee as a worker. So if it's a worker, we look at Sophie, and Sophie's employee number is 9. But what we are interested in, who is a supervisor. So here, boss number is given as 1. So using this 1, go back to employee. Now we are reading this employee table as a boss. So boss is employee number 1. What's the name? Alice. So that's how we can find it. Now it's a time to develop SQL statements to describe the logic that we just followed. Okay, so let's start. So we wanna select employees. What's the column name? First name. And from which table? Employee table. But as I told you, we are using employee table 2 times. So employee. So these 2 tables must be joined. Since physically it's 1 table, we need to use alias. So as an example, we can use WRK and the boss, BOSS, as an alias. So first here in the list, what we want to show, boss's name or worker's name, boss's name. So boss is the employee first name. Using alias, we can qualify. And then the following statement is join statements. So where now one boss has many workers. Therefore, foreign key and primary key matching is workers. I told you several times. Workers, boss number matched with boss's employee number. So please repeat one more time. Workers, boss number column is matched with boss's employee number. So this is the join condition. But in addition to this join condition, we have one more condition. What's one more condition? Whose name? Workers, employee, first name. So it's not boss's employee first name, but workers. So let's qualify with WRK and the first name. And the first name is Sophie. So let's add Sophie as the name for the worker's name, and then you will get the answer. The answer is boss's employee name. So the answer will be Alice. So let's try. So as you can see, here is the answer, Alice. So we are good to go. And I told you before, but as a kind of a practice for your exam, sometimes instead of this worker and employee, I may use different alias. So let's say just it is given as E1, and let's say it's given as E2. And here the first one, instead of boss, let's say I will use E1. Now, from here, the first part, we are using E1 and E2 alias, but can you decide the meaning of E1 or E2? Yes, because we are interested in boss's employee first name. So as you can see here, E1 is given, then we already know E1 is boss and E2 is worker. So therefore, here, what we need to describe, worker's boss name. So what is worker? E2. Who is boss? E1 or E2? E1. So whose name is Sophie? E1 or E2? So in this case, E2 is worker, so you can replace E2. So if there are fill in the blank questions with alias like E1 and E2, first you may need to figure out the meaning by looking at some hints. Like if this is given as a hint, you have to understand the E1, the meaning is boss. And then you can develop join conditions based on what you found from the hint. Okay, so let's look at another example. Find the departments where all the employees earn less than their boss. It's a kind of a really interesting question. So we want to find the departments where all the employees in that departments earn less than their boss. So how can we list those kind of departments? In the previous topic, we tried to find the employee who is earning more than his or her boss. How did you find it? Do you remember? So here, how did we find it? Select. The answer was Sarah. Workers. What's the employee? First name. And we found this from two table joins. So we use alias, employee as worker and the employee as boss. So we are using worker and boss. Where what's the condition is first we need to make a join condition. Don't forget. So we have to add workers and boss number is matched with the boss's employee number. And what is the other condition? The other condition is, it's not very common case, but we want to check whether workers' employee salary is greater than boss's employee salary. So we can just add this condition. So if you run the current statements, what you can find is the employee who earns more than his or her boss. So let's check it one more time, although we have done this before. So we know that the answer is Sarah. So as you can see here, the name is Sarah. Actually, we are interested in not employee name, but we want to know this worker's department. So here, instead of employee first name, we want to know Sarah's department. So department name. So if you add this department name instead of worker's first name, so now we can check what's the department name where workers can earn more than his or her boss. So we found that it's a purchasing department. So in the question, what we are looking for is we want to find the department where all the employees earn less than their boss. So we want to exclude which department? Actually, we want to exclude this department that we found, right? So here, this is kind of a list of a department. Although right now we have only one department, it could be multiple department. So outside, now we need to make one more select statements. So simply select department name from department table. So we are listing all the departments where we want to check department name, this key value is not in this list of department. So if there is a list, what we can add? Not in is the keyword. So note that again, department name checked, and this is matched with the list of department name inside the select statements. So let's run this. If you execute it, excluding one department, purchasing department, actually we show these 4 departments. Let's look at another practice query. So list the departments having an average salary greater than 40,000. So how can you get the average first? So we need to use the department or employee table. So we have a list of employee and employee salaries given here. And each employee has one department. So what we want to know is each department, like marketing department, for example, what's the average of salary for these 3 people working for the marketing department? So we are going to move step by step. So let's start with the average employee salary. So all the employees, average salary, how can you get this using aggregated function? Let's start with that. Okay, to get this, let's start with the select. What's the aggregate function? Average, AVG, and what's the column names? Employee salary, and from which table? From employee table. So you will get one number, the aggregated value, average employee salary. So let's start with this simple query. So here we got it, and the average is about $40,000. But now what we are interested in not just one average, but we wanna group them. So each department we wanna get different average. So in that case, we learned about a keyword group by. So in the employee table, there is a grouping category. That's which column? Department name. So department name is used as a grouping category. Then depending on the number of department name or the group name, we can get different average values. So let's run this first to get some idea. If we run it, now we have not just one average, but we have 1, 2, 3, 4, 5 average values. Why we have 5? Because we have 5 different departments in the employee table and they are grouped together. So now let's go back to get some a little bit clearer idea. Now we know that this grouping category department name can be listed together with this aggregate function because it's not just one value, but the number of average values will be matched with the number of department names. So you can list these two together. So let's get the result. Okay, so here is the result. Now you may get better idea. Each department, there are different average salaries. It seems that management is the highest, and here accounting is the lowest. And among those departments and average salary, we have one more condition. Average salary is greater than 40,000. So actually, we want to exclude the 3 departments shown here: accounting and the marketing and the personnel departments. So let's go back. And how can we apply the condition for this average value? We talked about having. So having keyword, and now we can apply the condition for each group. So this average employee salary is given here and it's greater than 40,000. So 40,000. So let's apply this condition and let's see the result. Yes, as we have expected, the result show 2 departments, management and the purchasing department, where average salaries are greater than 40,000. Okay, the last query is list the names and the supervisors of the employees of the marketing department who have a salary greater than 25,000. The result is shown here. There is only one, employee, Ned, and the Ned's supervisor name is Alice. So how can you find this information? And here the result gives you some ideas. We need to use alias, worker's name, and the boss's name. Okay, so let's do it. So we want to select employee first name 2 times, one for worker and the other one for boss. So worker's first name. So let me use alias work. And I think it may be a good idea to use employee and let's just specify alias first. Employee, and I will use both. Then first I will use worker's employee first name, and we wanna use alias given in the output. So let me just use as this one. I will call as worker name. And then there is another boss's employee first name, and we want to use alias again, and let's use boss name. So let me write down like this. Boss's qualifier, employee first name as boss name. So we use employee tables again 2 times. So we need to add a join condition. Again, what's the join condition? Now you may remember. Workers boss number matched with boss's employee number. So let's write down that join condition. So workers boss number matched with the boss's employee number. And a few more conditions we need to add. First of all, we add whose department. Workers department name equals to marketing. So let's write down qualifier workers department name is marketing. And one more condition is workers salary is greater than 25,000. So let's add that condition. Workers employee salary is greater than 25,000. So let's look at the result. So as you can see here, worker's name is Ned and boss's name is Alice. Okay, so now as the last review question about what we have learned, let's look at BOM one more time. So BOM is a bit of material, and we are showing this hierarchical structure, how to build a item. So parent item and the child item. Note that one child, for example, bolt and nuts, can be used for many different parents. So we have a kind of many relationship between parent and the child. So we need to break up this many relationship with associative entity assembly. So here, but parent and the child both are just parts. So we use one physical table part here, but there are two relationships, one to many. One is parent and the other is a child. So if you forget, go back to topic 6 and thoroughly review and understand this BOM. So finally, the last example of this topic. List the name of parts. So there are parent and children. So we want to see the list of parents' parts, and the parts are assembled with child item. So we want to list the name of parent parts and the total cost of child parts used to assemble those actually parent parts. So the result may seem to be like this. So here's the part ID of parent, and here are parent parts description. And then what we want to know is all the child items to make, for example, bicycle. But if there are multiple parts you need to use, we need to multiply quantity for that item cost. And we want to sum up all those parts needed to make this parent item. So you may understand that. First, as we have done before, let's think about the join statement. So start with how about select. Let's start with everything from we want to use part table 2 times. So part as a child and part as a parent. So let me add this part child assembly and part parent. Since we are conceptually using 3 tables, although physically 2 tables, we need to add a join condition. So I will not repeat to explain, but we can add this following join conditions. So let me see here, instead of and where parent part ID assembly parent PID, child part ID assembly child PID. So this is a join condition. So we now use all 3 tables. So first, let's start with the result of that. So let me copy, and if we execute it, since we put child first, so here the first part is child. So the part ID is matched with assembly's child PID. And actually second part here is the parent. So to rearrange those columns, let me replace star with parent and child information. So let's slightly modify the current query first. So instead of all the columns, I want to show first the parent part description. Let me add the parent part ID as well. So part ID and the part description, and the child part description, child part cost, And also we need to know how many of each child we need. So I will add a quantity column as well. So this is the column from assembly. So let's rerun this to get some better ideas. So here is the result. So here list of a parent column on the left side. And for each parent, for example, bicycle, we have several parts we need. And there is a cost for each part. And here is how many quantities we need. For example, if we look at frame here, we need 4 of bolts and 4 of nuts. So therefore, to make a parent item frame, what will be the total cost? So here, 20 cents with 4 bolts, so it's going to be 80 cents. And the nut, 40 cents. So $1.20 would be the total cost that we are looking for. So from this example, we know that we want to summarize this data based on this parent part ID. So we want to group them by part ID, and we want to sum part cost multiplied by quantity. So let's look at how to modify. So here, let's slightly modify. First of all, given this current result, we want this group by the parent part ID. And after we make grouping, here parent, each parent, and each parent part description, we cannot list all the child, but we need to get one aggregated value. That is not child part description, but we are going to use aggregate function. So we can get one value and the sum of child part cost multiplied by quantity. So we can get one value for each parent ID. So we can list this parent information together with this aggregated value of sum. Since this grouping category is matched with here the first column, parent part ID and the descriptions. So let's run this final result. So we can get this nice information for each parent part. So I told you frame, we manually calculated, we know that the total cost is $1.20 at 20 cents. So it confirmed our logic is correct. So here is the sum, the total cost of all the children to make this left side parent. So this is the last example, and this is the end of SQL module 3. And see you in the next module.